All right, in this video, we're going to talk about side angle side. So this one is kind of similar to side, but it's a little bit different. Okay, so we're going to talk about the differences and what we need to just kind of be able to note in just like the way that we do this one. Okay, so side angle side. So with this, what we're doing is we're going to have a pair of congruent sides. Okay, so it's like here we have AB has to be congruent to DE because they both have one hash mark. So if we have AB is congruent to DE, and then we have an angle, okay, this angle has to be included. Okay, so what included means, okay, included is found right here. Included just means that it connects the two congruent sides together. So we need to write that down. Included means that the angle connects the two congruent sides together. Okay, so in other words, the included angle means that it's going to be touching the two congruent sides. Okay, so two different ways to think about it. The word included means that the angle connects the two congruent sides together. And it also, another way that you can think about it is that it just touches the two congruent sides. However you want to think about that, that makes it easiest for you, it's fine. Okay, but if you hear me say the word included, okay, this is what we are referring to. Okay, the word included just connects these two congruent sides together. So our angles that have to be congruent are angle B and then angle E. And then the last side would be BC has to be congruent to EF. Okay, so if we have these three conditions, like it shows here in the picture, then we can say that both of the triangles are congruent. So triangle ABC is congruent to triangle DEF. Okay, so in our proofs, we're looking for something similar to this, where we have two congruent sides, two pairs of congruent sides that are connected by an angle that is in the middle of the two. Okay, so down here in this example, okay, the first thing that they give to us is that JM is congruent to NL. Okay, so we can fill that reason in with the word given. And while we do this, okay, go ahead and place your hash marks down. So JM is congruent to NL, so that's going to get one hash mark. And then the second thing that they give to us is that this angle JMN, so JMN is congruent to LNM, LNM. Okay, so that gets the one arc mark, and that is also given to us. Okay, now this next step here says that MN is congruent to MN. So this side is congruent to itself. This is the easiest one that we talked about in the definitions video. Okay, so this one is going to be reflexive. Reflexive is just when the side is, the two triangles share the same side, and then we say that that side is congruent to itself. Okay, so that's it for the reasons. Now this last one here is just saying that the two triangles are congruent to each other. Okay, and the reason for this would be side angle side, because our picture matches this one up here, where we have one pair of congruent sides. We have one pair of congruent angles that connects the first pair of congruent sides to the second pair of congruent sides, which is right here. Okay, so that's that one. Down here for number 5, okay, we're just going through the same process again. So we look at our given statement, AB is congruent to BC. That gives 1 hash mark. And then we know that this is a given statement. Okay, so we took care of that. And then we have BD, segment BD, bisects angle ABC. So ABC is this big one up here. Now, when it bisects, okay, remember bisects splits in half. Splits in half or splits into 2 equal parts. Okay, the word bi means 2. Okay, it's a little bit of English class. The word bi means 2. And then sex, we just, it's a fancy way of saying parts. Okay, so 2 parts and they're equal parts. Now, since BD bisects angle ABC, waiting for this thing down here to go away. There we go. Okay, this piece is given because it takes the exact words from up here and it just placed it down. The next step is going to be applying the definition of bisects. So that's where ABD, this one right here, is congruent to CBD, C to B to D. So this one is going to get the definition of bisects. Okay, just a little hint for you. Anytime that you see one of your key definitions, okay, whether it's up here in the given or down here in the proof, okay, it doesn't matter. The definition word, so the term that you're using is going to be listed first. So in this case, bisects is listed before we do our definition. So in line 2, we have our key term, and then the reason for line 3 is always going to be this definition. So the line after your key term for the reasons is going to be the definition of that word. Okay, just a little piece of advice for you. Okay, step 4. Okay, anytime that you see 2 triangles share the same side, okay, you're probably going to be using the reflexive property. Okay, so be looking for that. If you see something that is congruent to itself, or the same segment is congruent to itself, then that means that you're using the reflexive property. That's why I say it's the easiest one to remember. Okay, and then here, this last line, this one is also side angle side because we have 1 and 2, the 2 congruent sides, side 1, side 2, are connected by this angle, the included angle. So this one is also going to be side, angle side. Okay. So that's going to be it for side angle side. Okay, even up here it's included, tells you what, it just means that it's the angles between the 2 sides. Okay, so this activity here, this is similar to some of the things in the quizzes, right? So all you're doing is you're telling whether or not these are going to be congruent by side, 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 or side angle side. You're not using any of the other ones in this specific slide. Okay, so the way that you need to go about this is number one, okay, like this one right here has the 1 and then the 2, and then this angle connects both of those together. So you're making sure that the other triangle looks the exact same. So here's 1, here's 2, and then we had this angle connected together. So this one's going to be side, angle, side. And then the congruency statement, you're going to take your letters. So like if I traced 1 to 2, that would be triangle QYT. And then I would trace 1 to 2 on the other one, which is going to be C, K, and then P. Okay, so you have 2 things for each one of these. If you see this right here where the 2 triangles share a side, go ahead and give hash marks. So the reason I put 3 hash marks here is because we already had one that had 1, and then there's a side that already had 2. So this one would get 3, and then we would have side, side, side. Okay, for the congruency statement, okay, if I go 1, 2, and then 3, that's going to be A, D, and then C. And I do the same thing for the other one over here. I go 1, whoops, I go 1 to 2, and then 3. So C, B, A. Okay, that's pretty much all that you're doing. Now, there are going to be a few that try to trick you. Okay, like for instance, number 4. Notice where this angle is. Okay, this angle is not connecting 1 and 2 together. Okay, remember, for it to be side, angle, side, it has to be, the side has to be, or the angle has to be included. So it has to touch the 2 sides together. So in this one, you would say that you cannot prove this specific triangle because it doesn't satisfy side, 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 or side, angle, side. Okay. Pictures like this, okay, you have to really pay attention to them. Down here at the bottom, this is where the 2 triangles share the same side, so that's going to get the 2 hash marks. Okay, 1 and 2 are connected by this angle. This 1, this 2 is connected by this angle, side, angle, side. This one right here gets another set of hash marks, side, side, side. Okay, down here, this is one of the ones where you have to use your parallel lines. So there's 2 different angles that you can fill in, right? It does not, I need to figure out whether or not these 2 angles are congruent. Okay, and the way that we do that is, notice that we have a parallel line here, and then we have this parallel line here. Okay, this would be our transversal. Because the transversal, it cuts through the 2 parallel lines, and then we need the transversal to make up this angle here. Okay, so in this case, we can make it, okay, this one's going to be side, angle, side, because these 2 angles are alternate interior. We know that alternate interior angles are congruent. Okay, it wouldn't do you any good to say that these 2 dots are congruent. I mean, they are congruent because they're a vertical pair, but it's not going to do you any good in terms of proving this specific one. Okay, number 8 down here, you can't do anything with ED and AB, there's no way for you to say that they're congruent. Okay, so side, side's out of the question. Side, angle, side, though, is still in play, but we just have to figure out if we can say that these two angles are congruent. Well, remember with vertical angles, okay, the V is vertical, and then the A is the angles. Okay, vertical angles are across from each other, and they look like this. So we have this picture in our problem. So these two angles are congruent because they're vertical angles. So this one would be a side angle side, only because we can say that these two angles are vertical pairs. This one down here, you can't prove that these are congruent because this is not an included angle, and there's no way for you to figure out whether or not U and P are congruent to each other. Okay, so the CPC-TC assignment has some of this stuff in there. And that's going to conclude the side, and side, angle, side. Okay, the next time we do a video, it's going to be over angle, side, angle. That's going to be a video by itself. And then we'll have a video over AAS, and then one video over HL. But that's going to be it for side, angle, side. There is a quizzes over CPC-TC, and it includes some of this stuff. So make sure that you head over there and check that out.